This first question has to do with well-formed formulae, and because we're looking at a formula that has a bunch of negations in it, the rule that's relevant is rule number 2, that the tilde goes in front of the statement it is meant to negate. Now the thing to notice about this rule is that there's really kind of two parts to it. The first part is just that the tilde always does go in front of a statement. And then the second part is that that statement that it's in front of is a statement that it's negating. So how do we apply or check this formula using rule 2? And then why does it check out? Why is the answer that it's yes, that this is a well-formed formula? Well, we just build the sentence. H is a statement. All sentence letters by themselves are always well-formed formulae. They are statements in our language. And if we want to negate H, then according to rule 2, what we do is we stick a tilde in front of it. That is, this tilde's scope is just H. So what's happening here, though? We've got two tildes in the formula that you're being asked about in question 14. Well, it's actually not a problem. Here is a statement in the propositional logic. How do we know that? Because we just checked it out, and it is correctly formed according to the rules of formation. And we want to negate it. And how do we do that? We just apply rule number 2 again, and we stick a tilde in front of that statement. Notice that the scope of this outer tilde, this first tilde, is the whole sentence here, tilde H. As a bonus, if we're looking at main operators, remember the main operator is the operator that has the largest scope. The scope of that first interior tilde is just the statement that it's in front of, so just H. And this first outer tilde, its scope is tilde H. It has the larger scope, and so the main operator is this tilde. What's going on here is actually very similar to what happens when ordinary conversations, ordinary communication, when we use a double negation, where someone might say, for example, it's not true that Alice doesn't like to read. Why they would say that, it probably depends on context, and honestly, in the propositional logic, it's the same way. If we happen to be translating a statement in English that uses a double negation, we would reflect that in our symbolic translation. But there's actually a more common situation where you're going to see double negations, maybe even triple negations or something in the proof system. And so let's take a look at one of our rules from last week. It's modus tollens, and the rule is just that given a conditional and the negation of its consequent, we may derive the negation of its antecedent. So in the most straightforward cases of modus tollens, you've got maybe a simple conditional like that. You've got the negation of the consequent. And you're going to derive the negation of the antecedent. So far, no double negations. But let's take a look where you have a slightly more complicated conditional. And it's not only the conditional that can be more complicated, of course, but just for purpose of this example, suppose that we have a conditional tilde D horseshoe C. Something, if the Dodgers don't win the pennant, then Charlie will be very sad. And suppose, either as a premise or another prior derived line, we do have the negation of the consequent. Well, we are entitled to use modus tollens because, after all, we do have a conditional. We do have the negation of the consequent. But here's where you're going to see a double negation. By the rule, what we are allowed to derive is the antecedent negated. Right? We're allowed to derive the negation of the antecedent. And so that actually looks like tilde tilde D and not just like D. For sure, tilde tilde D and D mean the same thing, in the same way that it's not true that the Dodgers don't win the pennant means that the Dodgers win the pennant. However, the way that we form negations in our symbolic language is determined by rule 2, and by rule 2, we just stick the tilde in front of the statement that we're trying to negate. So by rule, again, we are entitled to take this antecedent here and derive its negation. Okay. All right, so the next question was also another hard one, as you can see, and it's one that has to do with the idea of vacuous or technical validity. Now, we talked about this a little bit in some of the discussion section recordings, and it's also discussed towards the end of 7G. But here I actually want to walk you through a couple of sort of mocked up truth tables to try to illustrate why an argument that has a self-contradiction as one of its premises and really anything at all as its conclusion. Here you're being asked about a contingency, but really anything at all, that argument will be valid. So we don't know what P and Q are. P is a randomly selected self-contradiction, Q is a randomly selected contingency, but that actually gives us a lot of information what the truth table would look like. Under P, you're going to get all and only Fs. Since I don't know exactly what P is, I don't know how many Fs. That is to say, I don't know how many rows of Fs there are, but they're all going to be Fs. Q is a contingency. I don't know what it is still, so I don't know how many T's and F's there are, and I don't even know which rows have the T's and F's, but I do know that it's going to be a mix of T's and F's. So that's what the truth table will basically look like. How does this help me answer this question about validity? Well, the test for validity is an absence test. We're looking for the absence of rows in which the premises are all true and the conclusion false. As long as there are no such rows in the truth table of an argument, then that argument is valid. Even in this mocked up partial truth table, we can see that there will indeed be an absence of rows where the premises are all true and the conclusion false, granted for a technical reason, because there will be no rows where all the premises are true. We will actually come back to this idea a little bit in about 2 weeks, and so do let it mull in your brain. Do think about how the definitions of the logical concepts work together in questions like this and also just in applications like this. But when we get to a proof method called indirect proof, we'll actually see something related to this again. So in part, I'm just saying, if it's still kind of confusing, hold your horses. We'll come back to this. The last question I wanted to look at was the third hardest on the exam, at least statistically, and it is also about validity. This one, though, I'm going to work through just using sort of chapter 1 intuitive notions here. And at the heart of this question is what validity means. Validity means that the premises guarantee the conclusion. That the premises are true and the conclusion true is not enough to show that guarantee. This is actually why the truth table test is what it is. In order to show validity, we have to show that it's impossible for the premises to be true and the conclusion false. And in terms of truth tables, if you think about it, just because you find a row where the premises are all true and the conclusion also true, that doesn't show that the argument is valid. You have to go on and check and make sure that there aren't any other rows where perhaps there might be true premises and false conclusion. It's the same idea here. And in fact, we can take a look at an example. This argument, for example, has all true premises and a true conclusion, but it is in fact invalid. If bats are mammals and they are warm-blooded, that is true. Bats are warm-blooded, that's also true. And bats are actually mammals. However, pretend just for the moment that you didn't know anything about bats. Or at the very least, you didn't know that they were mammals. And so someone presents you with an argument, right, to try to convince you that bats are mammals. And they say, well, look, if bats are mammals, then they're warm-blooded, right? After all, that's what mammals are characterized by, is that they're homeothermic, that they can self-regulate their body temperatures. And then they present you with further evidence saying, you know what, look, bats are warm-blooded. I don't know, they take a scan of a bat or however you show that a bat is warm-blooded. And they say, there, look, see, So if bats are mammals, then they're warm-blooded, and bats are warm-blooded, then we also know that bats are mammals. You should run screaming from that person because they have just laid on you the fallacy of affirming the consequent. Now, you don't need to know that name, but in chapter 8 now, you have the tools to exactly see what's going on here. If we symbolize this argument, let's do it this way, then what purports to be going on here is that given a conditional and the affirmation of its consequent, we're trying to derive the antecedent. And of course, there's no mention of rule MP, but this is the common mistake. This is a common wrong for modus ponens, is to take the affirmation of the consequent and use it to try to derive the antecedent. It's a fallacy because it confuses necessary and sufficient conditions. We had the tools to show that this argument was invalid in chapter 7 because you just do a truth table and you would indeed see that there is a row where the premises can all be true but the conclusion false. But here in chapter 8 too, we have a new way to explain the wrong. Because for modus ponens, what we need is the matching antecedent. When we have the matching antecedent, then we're entitled to conclude the consequent. If you have more questions about exam questions, please do let me know. You can use the DBs, but I actually recommend focusing on the new material. As you have experience now for a week, the new material is clearly related to chapter 7 and chapter 1. However, we are in the proof system. We have moved on from truth tables, that's to say, and so really sort of figuring out the rules, figuring out proof strategies, figuring out what we're doing now, that should really be your main priority. And so I encourage you to reach out to me directly, use Canvas Inbox, and we can talk about any exam questions that you want to talk about.